Hello there. In our previous episode, we discussed about how we can compile our code. And now we know how to compile it and make it ready to be used in our engine. In this episode, we will talk about variables and how we can define them, the different types that we have. Also, an initial introduction into the pointers and macros in Unreal Engine, specifically in this case, U properties. It would be very interesting because it's the first step in our way to implement our own feature in the engine. I'm really excited about it. Let's then dig into it. Okay, let's start with the basics. A type defines what kind of data a variable can hold. A variable is a named container that stores a value of that type. Unreal Engine supports standard C++ types, Unreal specific types, and Unreal object types, which come with the reflection and garbage collection. Understanding which category you are using is critical. Value types in Unreal are the simplest one to understand. They store actually data directly, not references to something else. We can categorize them in the two main categories, primitive value types and struct value types. The primitive value types are like int32, float, double, and bool. And for the struct ones, we have a vector, a rotator, a transform, and different type of string or text that we have, f string, f name, and f text. Let's break this down. Int32, float, double, and bool behaves very similarly to a standard C++ one of them. Int32 is 32-bit signed integer, float is 32-bit floating point number, and double is 64 bits and more precise. Bool is also a true or false value that you can use when you are discussing about the logics. These values live directly inside the variable. If you copy them, you copy the data. If the variable goes out of scope, the data disappears. There is no engine magic here. If you know a standard C++, you might also know the ints here. But in Unreal, we use specifically int32. A standard int can change size depending on if you are on a PC or console, but int32 guarantees that consistency about crossing all platforms. In this case, we can say int32 is a whole number, float when you need the decimals, and bool is a way that you want to define if something true or false, is a door open, is a player dead, or something similar. When we are thinking about the struct value type, a vector is a struct containing three floats, x, y, and z. F rotator stores rotation as pitch, yaw, and roll. And F transform combines location, rotation, and scale at the same time. These are still value types. That means they live directly in memory, they are copied by value, no garbage collection, and no pointer required. When you pass an F vector around, you're passing the number themselves. This is fast, predictable, and safe. About the other three types that we mentioned, they are mainly about text. These types are working somehow similarly, but with slight differences that define them. Where do you need to use them, or it's better recommended to use them? If a string is a mutable string, useful for runtime logic, fname is immutable, hashed identifier, or great for comparison, and ftext is localized text, used for UI and player-facing content. Even though they look complex, they are still value type, and Unreal handle their internally memory safety. Let's now go to the object types. For the object types, we can actually categorize them in two major categories. Both of these categories behaving similarly, and the only reason that we are categorizing them is the way that Unreal Engine is handling them. Some examples for the first category that we call them A actor types is A actor, a pawn, a character, and custom actor that we can make. All of them are inherited from actors. We will learn about the inheritance later when we talk about it. But just to know, everything that you can put in your level that has a certain location, rotation, and certain position in the world, you can call it actor. And everything that defines some behavior without necessity that you put it certain at certain place in your environment can be called as a U object. The U object can be components that we use or any other types that you do not need to actually put it inside your level. But the important point about these things is how you reference them. You need to always store pointer to them. They are created dynamically, they are managed by engine and participate in garbage collection. You must track by reflection system as well. Now that we discussed about the pointer and mysterious things and maybe confusing things, it's better to maybe discuss it a little bit more. You will see variables like a actor star, my character. It means a character that has a type of a actor, but what's that star mean? That changes everything. This is not a container that holds a character. This is a container that holds a memory address. Let's think about it in this way. When we have a f vector, a value type, it's like building a house directly inside your backpack. You carry the whole house with you. But when you say a actor star, a pointer to that a actor is like carrying a slip of paper with a street address written on it. It means the character lives somewhere huge in the computer's RAM, the world that we have, but you do not want to shove that whole massive character into the tiny variable. Instead, your variable just say the character is located at memory address of 0x1234. And that's it. You know where to find it, and whenever you need it, you will just go there and grab it instead of carrying it by yourself. It has two main reasons, efficiency and shared state. If I have a generic target variable, I want it to point to the specific enemy standing in front of me. I don't want to create a clone of my enemy. I want to affect the original enemy. By using a pointer, for example, you say target, then take damage. I'm telling the computer, go to the address written on this slip of paper, find the actor who lives there, and hurt them. Another point is why we are using this A and U before this actor, pound, character, or actor components, a scene component, or a static mesh component. They are just a naming convention by Unreal. We used A when we are using the object that inherited from actor class, and U when we are inheriting from U objects. It also helps us visually to immediately realize what's the parent class for them. Value types are stored data directly. They are copied on assignments and has deterministic lifetime. It means when we create them, we are certain when they will be removed from the memory and they are destroyed automatically. On the other hand, object types, they store memory address to that objects. They refer to engine managed objects and we need garbage collection for them. Otherwise, we cannot remove them from memory. And we should be very careful when we are handling them because it's dangerous. As we mentioned before, we are having an address to this object. There is one cache with the pointer. Since your variable is just holding an address, what happens if it holds an empty address? It means you have an address, and when you go there, nothing exists in there. It's like a black hole. And this is called null pointer. If you try to call for a null pointer, your game will crash immediately. It's like trying to drive to a house that doesn't exist at all. Unreal panics and shut down. So the golden rule of C++ programming in Unreal is always check if your pointer is valid before using it. That's it. Then let's go into Unreal Engine and try to visualize the thing that we learned about it in our code. See you there. You know, in Unreal Engine Blueprint, you can create variables here, defining their types, and then giving a name and using them. Here you have different types, for example, float, integer, and name, which is similar to what we learned in the theoretical part of this episode, but it's a little bit different. You do not see that f name or f string, but they are actually same thing behind the scene. And also you can get this variable, setting the new value for them, and etc. Let's see what we can do similarly in C++. I will remove a variable that I made here because I do not need it actually. I'm going to the writer to see what we can do in there. In the public accessor of our header file, we can define our global variable. We will discuss about the local and global variable later, but here we would like to also just define some variable that is accessible through our whole code. I have the header file and C++ file here. The first variable or primitive types that we learned was int32. I will define one of them and call it, for example, inventory capacity. Why I'm using int32 here? Because it's a whole number. The number of items that I can put in my inventory is a whole number. I cannot put 2.5 items in my inventory. It's either 2 items or 3 items. And then I can give it a value. For example, it's a game that I can have 5 items in my inventory and I can work with them, and it's an inventory capacity. I can later on increase the capacity, for example, in begin play for any reason. If I need to increase it, I can say inventory capacity, and I want to increase it by 1. I can do it like this as well. Or I can increase it by certain number, like doing it like this. That it will add a certain number to my inventory. But just know we can increase it by whole number, and it's a whole number by itself. On the other hand, if I want to know a distance to targets, it's not a whole number. It can be a decimal value. Then I need to use float or double if it's a larger value. Distance to targets, I can then define it, for example, as 1000.5. I use here f at the end because it's a float value. Or I can have a condition for my character. For example, either my character is flying or diving or doing something else. Then this condition will be a Boolean. It's either true or false. I can define a bool here, and I will call it is flying, and I will call it to false initially. But later on begin play again, I can say, for example, is flying is equal to true. Or I can have a condition that will set that one to the true. These are the main primitive types that we use. We have also a double that is larger, or int64 that is larger whole numbers, but we can discuss about them when we reach the condition that we need them. Okay, imagine you would like to store the location of the character. It's not a single value, it's a vector. It's a combination of 3 values that defines the location of the character in 3D world. In that case, we use f vector here and define, for example, a character location, and we can initialize it by using the f vector keyword, and then defining that location. For example, it's at 0, 0, and maybe 100 and 0. It's just it's 100 elements in the y-axis. Just to know, in Unreal Engine, the units by default are centimeter. It means it's 1 meter in the y-axis towards the center of the world, and 0 distance to other axes. But if we want to define the rotation of our character, which direction it's looking, we can use f rotator in that case, and we can say character rotation. And if, for example, our character is having some angle towards the pitch value that I will show you what's the meaning in a separate lecture, we can define also here the pitch value or yaw or roll that our character object has. Also, we can later on define an F transform for anything that is a collection of transforms that we would like to use. It's a collection of f vector, f rotator, and another f vector for the scale. It means location, rotation, and a scale of our character. That's good. But the next type of structs that we had was a type that we used for storing the string or the text that we need. For example, we would like to store a name of certain socket on the character skeletal mesh. The socket is a place that we will use for attaching, for example, another object to it. In that case, I would use fname because it's a fixed value and I will not change it over time in my code. Then it's faster to also iterate over it and compare it with other stuff. I will call it, for example, the armor socket name, and I will give it a name, arms, for example, armor socket. But you might also ask, what's then the difference to the f string? We can also define it in the same way. For example, I can say the character name, it's John. They are defined similarly. If anywhere in my code, I want to modify this character name. For example, it's John as a first name, and I want to add a last name to it. In that way, if I try to say, okay, character name plus Rick, it's totally fine. I can do it because it's mutable. But the f name is immutable. I cannot do the same thing there. If I say armor socket name and I want to add something similar, but for example, a number to it, I will get a compiler error. It doesn't let me to do that. It will say it doesn't define that. We would think maybe that's a limitation for sure, but this limitation has benefits. It will limit us from modifying something that should not be modified, but it also makes it much faster to compare. And it's a benefit in many cases that we will like to quickly compare two types of the text with each other when we are having a text-based comparison. Okay, now we have our parameters. Let me remove the implementation that we have in play. But let's see what we can do with them in blueprints. I will compile my code by pressing Ctrl Shift B, and the live coding will be enabled. I will see if I have any error. That's most probably not, because it's a simple definition. And now I will go in Unreal Engine to see if I have any sign of that variables. First of all, here I will check whether I have the show inherited variables, but I do not see anything here. Also, if I now search, for example, what we had here inside our code as, for example, inventory capacity. If I search for it, I cannot find it because we didn't make any links to our blueprints from our C++ code. If I want to make any link to it, or if I want to give it access to be able to modify it using Blueprint because it has lots of advantages that we will use a lot later on, we need to use a certain macros in Unreal Engine C++ codes. This macro is called U property. The U properties are important in different ways. But the way that we will use them here, and it's critical for us to understand them, is a contract between C++ and Unreal Engine to how to show this item in there. For example, the first thing that is important is editor exposure or editor specifier. I would like to define how this item would be exposed in my editor by, for example, saying edits anywhere. It means this item can be edited anywhere inside my blueprint, either when I am modifying the blueprint itself, or if I add a copy or instance of that blueprint to the level, I can modify that one, or anywhere else that I need it. Let's get back to see where I can find this inventory capacity. If I double check my Unreal Engine blueprint class that I had, I might find it somewhere. It's here in the category of sample actor, which is the name of the C++ parent class. And then I have inventory capacity. I can modify it here. For example, I can enter 10. And also, if I add another copy of this object to my Word, then again, I can also modify it here. But can I also modify this variable using my blueprint? I will search for it. Inventory, and I cannot find it at all because I didn't give it access to the modification. I will go more in depth later about what are the all specifiers that we can have, but it's good that we know a little bit about it. If I want to have access to read and writes, then I can use another specifier that we call it access controls. I can use blueprint read and writes. And if I now compile it, I will see two differences. First of all, in my Unreal Engine blueprint code, if I go to the My Blueprint part in the variable sections, I will see the sample actor here to be visible. Also, I can drag it here and either get it or set it. I can modify this value. And also, if I search for it now, I can see these two types of usage for that. It means I have access, first of all, to my variable that I defined here inside my blueprint to define the value for it, initial value for it, or a value for the instance. Or I can also modify it over time or get that value and use it in my blueprint. It gives me lots of flexibility further on. But sometimes it makes it chaotic to have everything under sample actor category. If you have maybe 20 different variables, it's difficult to handle them. Unreal gives us another specifier that helps us a lot in this case. If you type category here and then give it a name, I can call it, for example, a character. And then inside the character, I would like to also have a subcategory as the capacity or maybe setting. And now if I build it, I will see that I have now a subcategory of character and then another category of settings, and I put my variable in there. It helps me a lot. And this symbol define how I distinguish between different parts of my categorization. It's very handy and it will help a lot. Okay, now that we discussed about our value types, let's go into our object types and have a quick look at it because going in depth in there needs more time and we will go deeply in there when we want to discuss about some components and also actors and what we can there. Let's get back into Unreal and see how we define it. For example, we press add and then clicking on the static mesh and it says, okay, the static mesh component is used to create an instance of U static mesh, or the scene component will create a U scene component objects. If I want to create a reference to that, I will define it here. For example, if it's a actor, I will use a star afterwards to define that is pointer, and I will say it's my target actor. And it's initially referencing to the null pointer because I do not have access to any actor in there. Or if I have a certain maybe component that I want to reference to, for example, U static mesh components, that I will put star because it's again a pointer to it, and I will define, it's better to have a complete name for it, static mesh component. And I will give it also a null pointer. Here it's highlighted this one and it says object member target actor can be destroyed during garbage collection, resulting in a stale pointer. Because we did not use the U property here, it might accidentally get destroyed over time. In order to avoid that, we will use U property micro here, and it will fix the issue for us. We have access to this object as long as we need it, and we did not destroy it. I can do the same thing here, and it will also fix that issue there. However, even though I defined its U static mesh component, I will not see these objects if I compile it in my blueprint. And it will be a topic for the next episode that we discuss how we can add another component in our blueprint that we see it here. But it's good at this point that we at least know how to create components or actors or variables that we need. And we will later on will get access to these items and we will use them. I have the feeling now we start actually our first step to implement something for our Unreal Engine blueprint and class that can be used later on. It's getting very exciting. Looking forward to see you in the next episode and see you there. Bye.